Did you ever think creating wind on plants and trees in Unreal 5 would be so easy? In this tutorial, I will teach you how to create the wind effect in trees using a master material and also have a general controller for all your plants. I promise your knowledge of materials will be different before and after this tutorial. Before we start, if you're interested in this content, give us a thumbs up, hit subscribe, and join our newsletter for exclusive educational tips and updates. Stay tuned for more exciting videos. This master material is for my plants and contains all the necessary nodes for a plant. All the things we are going to do are going to happen on this input world position offset. So let's get started. The easiest thing we can do at the beginning is to create the node simple grass wind. I connect it to the world position offset. Now I need to define its inputs. Right-click on each input and press Promote to Variable. This is one of the quick ways to create a variable. I set the default intensity level on 0.15, set the weight on half, and set the speed on half as well. Now let's see the result. As you can see, this flower, which is from Quixel Bridge models, is swaying in the wind. But the problem is that its stem is also swaying and is not connected to the ground. Let's fix it. To solve this problem, we can use the vertex paint feature, just like Quixel uses the green channel in its models as a mask. Since our model is for Quixel, we can see the green channel output on the base color. As you can see, the stem parts are white and the upper parts that should sway are black. If we want to use vertex color for wind, we need to use the lerp node. We set the wind output to A and B to 0 because we don't want the wind to affect the white parts. We get the alpha value from the green channel of the vertex color, which acts as a mask. We connect it to the world position offset, and this is the result of our work. Perfect. You can use any 3D software to draw vertex color on the plants you've modeled and apply this logic on them. I myself use the green channel, which works easily when I put my master material on Quixel objects. Now, what if we don't have the time to vertex paint? No problem, I have a solution for that. We simulate the vertex color through a gradient. This gradient should act based on the size and pivot point of our plant. Let's create the gradient. To see the effect of this gradient, first, we create it on the base color and then add it to our wind. I start with the world position, and you can see that the result changes based on the object's position. In order to keep the result consistent on the object, I use the transform position node to change the result from absolute world space to local space. Look at the result. Now, by dividing the result by the maximum of the local bounds object, I scale our gradient based on the object's size. As you can see, we are close to what we want. To have more control over our gradient, I add a parameter called gradient offset to the result so that its position can be adjusted. Then, using the power node and a parameter called gradient power with a default value of 1, I adjust its intensity. Since our gradient is in color, meaning it is applied in all directions, I set it to an elevation mode using the component mask node and choosing the blue option. As you can see, this result is the opposite of what we had in the vertex color, so I reverse it using the 1- node. So this is the gradient that works on all objects. I bring our gradient calculations to the desired location and return the base color to its initial state. To organize the node comments and group the wind parameters, I create a group named wind to have tidy instances. Now, let's assign our gradient to alpha. To be able to choose between the gradient and vertex color later, I use a static switch parameter node called useVertexColor. I connect the vertex color to true and the gradient result to false, setting the default to false and connecting it to alpha. This is the result of our work. And here is our instance with all the parameters we created. This effect is great for flowers, grass and leaves, but what about tree trunks or branches? As you can see, the result is terrible on tree trunks. I go back to the material and create a simple wind effect switch parameter called enable grass wind, so you can turn it on and off. I assign the effect to true and a value of 0 to false. Then I connect its output to world position offset. As you can see, the wind is now inactive on the trunk. Now let's create a swaying effect on the tree trunk. First, I disconnect the simple wind effect. Don't worry, we will reconnect it to our nodes later. Now let's create the swaying effect below. I want to get help from a tool called Rotate About Axis, which will continue to fill these inputs. I use world position for input position. For the pivot point input, I create a vector 3 with a value of 0, 0, 0, and using the transform position node, transform it from local space to world space so that we have our object's pivot point at 0, 0, 0. This is our origin of tree. I connect it to the pivot point. Two more inputs are filled using the wind node. First, I connect the normalized wind vector to normalized rotation axis. By assigning a number like 1.4 to the rotation angle and connecting the output to world position offset, we see an initial result of the work. As you can see, the tree is rotating downward. Interesting. Let's go and get it closer to what we want. Well, we need a smaller and animated number. The wind speed output has these capabilities, and along with the sine base node will be the base of our work. Let's build its calculations. First, I divide the normalized wind vector by a tested number of 4.5. This number is our turbulence size. Now I multiply the wind speed by a parameter called wind speed and set its default to 1.2. I add these two together. This is what we will connect to sine for rotation angle usage. The result is quite intense, right? Let's fix it. I create space to add more nodes. Before and after the sine node, I add a multiply node and connect a parameter called sway intensity with a default value of 0.02 to both of them. The result becomes smoother and the tree is rotating. Let's make the rotation a bit more random. I add another layer of sine and multiply nodes. Add a number as an offset to the top output and set it to 0.458 to help randomize the result. Connect it to the first multiply node. Now, I connect sway intensity to the second multiply node. I connect the first multiply node to a number of 0.256 to help with randomization. I add these two parts together and connect them to rotation angle. The result is much better, but we don't want the lower parts to sway. We need to ensure that the lower vertices remain fixed, so we need to calculate the distance of vertices from the pivot point. Let's fix it. I place a multiply node after rotate about axis and start adding calculations that connect to this multiply node. Using the distance node, we calculate the distance mentioned earlier. I assign the previously calculated pivot point to A and the vertex position from world position to B. I divide the result by the object radius and square it by multiplying it with itself to intensify it further. Finally, by multiplying it by a parameter called sway controller with a circuit of 0.005, I create access for it in instances for myself. I connect it to the multiply node and then connect the result of the multiply node to world position offset. The result is very subtle. By changing sway controller to 0.1, we achieve this result. Excellent. I'll tidy up our calculations to get rid of the mess. We need to create this feature in our material so that we can turn this effect on and off. Using a switch parameter node called enable sway, I connect our effect to true and set the value 0 to false. Here, the results of two effects we created for wind come together, and we can add the outputs of two switches together to use either of these effects individually or simultaneously in our plants. Now let's connect it to world position offset. Don't forget to group parameters related to sway under a group named sway. As you can see, you can activate the sway effect on the trunk and adjust its parameters. Let's see the result on a complete tree. This tree includes trunk, branches, and leaves, each using the master material we created. Check out its materials, where one material is for the leaves and the rest are for the trunk and branches. Let's enable sway for the trunk and branches. It's important that the sway parameters are consistent across all parts of the tree so that all components sway together. See, the trunk and branches are swaying, but the leaves are still. For the leaves, we need a simple wind effect along with sway to ensure they sway in harmony with the trunk and branches. The settings for the simple wind effect are accessible. For example, I set its intensity to 0.2. As a result, you can see that the leaves sway along with the trunk, in addition to the simple wind effect they already have. Now, I want to create an external controller that allows me to change the wind intensity and direction for all trees and plants using a parameter. I use collection parameters for this purpose. Inside my collection parameters folder, I create a material collection parameter from the subset of materials and name it MPC_wind. For wind intensity adjustment, I set up a scalar parameter named wind intensity with a default value of 1 for wind and a vector parameter named wind direction with a default value of red. Remember that the blue value is for the z-axis direction and it should not be used excessively. I go back to our master material to utilize this collection parameter in it. We need to add the direction to the normalized wind vector by creating a collection parameter node. I select the wind collection we created, choose the wind direction parameter, add it, and finally connect it to normalize rotation axis. You'll notice an error because our vector output is float 4, but we need to add float 3. So I use a component mask and select RGB to convert it to float 3. To use the intensity we created in our collection, I go to the sway controller section and multiply it by a collection parameter node. Select our collection and set the wind intensity parameter. Don't forget to organize the entire sway section within a comment so that it looks more organized. I apply the intensity parameter to our simple wind and multiply it with the material's own wind intensity parameter. Now, by changing the collection wind parameters, I can control the wind intensity and direction of all the plants in the scene. As simple as that. I increase the number of my trees and realize that this effect creates a repetitive motion on too many trees. Now, I want to create a random number based on tree positions using some calculations to influence our wind intensity. In order to see and understand the momentary effect of our calculations, I will first perform these calculations inside base color. I make a position object, and since we are going to have the location of the trees in front of X and Y, I mask it twice and put R in one and G in the other. Divide them by 10 to adjust their influence range. Pass them through two syn nodes and add them together. If I connect the result to base color, you'll see that tree colors are black and white based on their positions. I don't want them to differ that much, so I use a clamp and set the two parameters position min influence with a value of 0.2 and position max influence with a value of 1 to min and max. Now let's see the output. Excellent, our calculations went well. So I revert the base color to its original state and move our calculations to where they should be. I want to use these calculations just before the switch node in the sway section, so I create a multiply node here and assign the result of our calculations to it. As you can see, the wind does not affect all trees in the same way, and it is more random. Don't forget that you can have our master materials, which includes this material with wind capabilities as well. Like, subscribe, and leave us a comment. Until next time.